No, they're short.
Okay, guys, we're starting. All right, this is going to be the first review. This is a review for fluids, test review, and it'll be one. This will be the first one. Okay? Now, what I'm going to do is I have a test. That you can't see, only I can see it. And I'm going to go over the important concepts for the test. Okay? Is that okay? All right, now, first thing I want to do is I want to talk about pressure. Because with pressure, we kind of understand the whole concept of buoyant force. Do you remember what pressure is? Pressure has to do with forces, correct? Force per unit area is pressure. So there's a relationship between pressure and buoyant force, is there not? Now, you've all done the reading, you've all done the outline, so let's do the first review by looking at simply pressure, okay? Now, pressure is pressure of a fluid, is rho GH. Is it on? It's on? Okay, that's okay. The pressure is rho GH. Right? So, if you're in the ocean, or you're in the Caspian Sea, or you're in the Black Sea, or you're in Lake Baikal in southern Siberia, deepest lake in the world, Lake Baikal. I actually have water from there. Weird, huh? I do. I have water from Lake Baikal. Anyway, if I go approximately 10.3 meters down in any of those bodies of water, what will be the pressure? Approximately. Yes, densities will vary, etc. But approximately, what will the pressure be if I go approximately 10.3 meters down? What will the pressure be?
103,000.
What is it going to be?
103,000.
103,000 pascals, right? Now, let me ask you this. So, if I go 10.3 meters down in any body of water, the pressure is going to be the same? Is that right? Is that what you're saying? Make a decision and stick to it. I suppose. Mr. Convincing here says, I suppose. That's the way to take ownership over this. Let's take ownership over this. Is that true, yes or no? Yes. To the best of your ability, Jack, is that true?
Sure.
No, not sure like. Sure. It sounds like you're mocking me. Are you mocking me? A little bit? Okay. No. Yes, that's absolutely true. It doesn't matter the body of water. If you go 10.3 meters down, it's the same pressure. If you go 1 meter down, it's the same pressure. It's all the same. Clear? It's all the same. What would the pressure be if you go down 1 meter? If you go down 1 meter, what would the pressure be? 10,000 pascals. So it's all the same. Doesn't matter the body of water. Now, let's look at an object relative to pressure. This is submerged in a fluid. Okay? That's submerged in a fluid. Where on the object is the pressure greatest? The top, the bottom, the middle, where? Why the bottom of the object? Why the bottom of the object? Exactly. Pressure is dependent upon the depth. We always say height, but isn't that the same as depth? Right? The depth of the fluid. So the pressure is high here, and the pressure is low here, relatively speaking, correct? You see that? You sure? Excellent. End of part 1. Thanks for coming.